So, good morning, everyone. This is Prashant Jamwal from Nazarbayev University in Kazakhstan. I welcome you all to this session, which gives us, amidst this COVID-19, gives us a chance to um, go through very interesting topic of today, which I've picked up for everyone. It's called the title is Artificial Intelligence, and I'll briefly talk about um, after introducing the topic, I'll talk about its applications and specifically the applications which we are working on and we found it more useful. So I'll start my presentation with a um, few um, um, few things about me because I was graduated from one NIT in India and then did my master's from IIT Roorkee and then did my PhD from University of Auckland, which is, I mean, these two institutions are there. They're pretty old, as you can see. IIT Roorkee is close to 173 years old, whereas University of Auckland has done as many as 137 years. But presently, I'm working at the Nazarbayev University in Kazakhstan. The university is situated in the capital city. Previously, it was called Astana. Now the name has changed to Nur Sultan, and I work in the Department of Electrical and Electronics. Now, I'll give you a brief introduction of my university here. After that, I'll start my
Welcome to
presentation.
Nazarbayev University, a modern and rapidly developing university located in the heart of Eurasia. Nazarbayev University aims at education of the new generation of leaders of the country in science, technology, enterprise, medicine, public administration, and education. Nazarbayev University has a unique infrastructure. Thanks to a wide range of services and opportunities, we strive to create a thriving community where everyone can live, learn, develop new ideas, grow in a personal and professional way, and of course, enjoy life. There are 9 buildings of the university, with a total area of 100,000 square meters, which connects one large atrium with a tropical garden. The university has research centers. They are equipped with modern laboratories and high-tech equipment. The centers conduct research in the field of renewable energy, physics, and high-energy technologies and medicine. The university library has the largest English language collection of information resources in the country. It provides free access to more than 57 full-text scientific databases, to more than 1 million articles from popular scientific journals. In the knowledge repository, you can find those books that are not in all Kazakhstan and the CIS countries. Nazarbayev University campus is devoted to help students, faculty, and staff experience the full scope of university life. Cafes, canteens, shops, laundries, all these help students to focus on studying in the most comfortable environment. Sport is an integral part of student life at Nazarbayev University. Nazarbayev University Sports Center is a 6,000 plus square meter multi-sport complex open for NU community. Gyms, football fields, tennis courts, Olympic-sized swimming pool, and much more. Senate Hall is the venue for particularly important events. For example, PRC Chairman Xi Jinping, British Prime Minister Tony Blair, and many other prominent personalities spoke here. Nazarbayev University is an internationally recognized research university whose principle is the integration of education, science, and innovation.
So I'll be talking about artificial intelligence today as the topic is. The agenda is that I'll go through these headings such as machine learning, different AI approaches, neural networks, genetic evolution. Then I'll talk about what is neuroevolution. So yeah, starting from the overview of artificial intelligence, I'll talk about what is the difference between artificial intelligence and the machine learning. There are many myths around this, and I'll try to explain things more clearly. What are different types of AI and machine learning algorithms? I'll speak about deep neural networks, genetic evolution, and then at the end, I'll talk about application of all this technology into the research, and specifically the research that we conduct here. I'm delivering this talk on artificial intelligence in a more general way to the general audience, but I'm pretty sure the curious ones will be able to find some some of the very important and relevant research questions from this presentation. So, when we talk about data, we collect a lot of data. We have a lot of sensors these days, cameras, and different kinds of sensors. We collect a lot of data and then we process. What is this data is all about? So, we normally come across 4 or 5 kinds of data, including the text data, the image data. We also have animations. We also come across data in the form of sound and the videos. So when we process text data, now all this data has to be processed by a computer. So it has to be converted in some sort of a language that the computer can understand. When we convert the text data, we come across 2 kinds of data mainly. One of them is a quantitative data, which is perfect with numbers. But then we also come across categorical data, such as men, women, king, queen. Now, to understand these kind of categorical data, for a computer it might be difficult because the computer can make out the distance between 4 and 5 or 4 or 10, but it cannot make out a distance between king and queen or man and women. So there we have some challenges. We do work on image data and then use an algorithm which is called convolutional neural network to understand and to store it in a bitmap. Um, I'll talk about some challenges in this convolutional neural network as well later on. But for now, I'll just quickly browse through the animation data that we have. Is again a bunch of frames that can be given to the computer in the form of binaries. We do come across a sound data sometimes. The sound signal can be converted in terms of uh, frequencies, in terms of data, uh, after proper filtering. And if you come across a video data that normally our cameras are recording, we process it again the same way to extract more and more information. Now, um, when we collect data, we need to do some sort of analysis. Now, this analysis normally is of 3 kinds. First, we do a descriptive analysis to understand what has happened, and a predictive analysis is done later on, which would say what could happen if you use a prescriptive analysis, which is the third kind of analysis, which says what should be done or should have done. So, for instance, um, if you take an example of a predictive analysis, it's kind of, um, for instance, you know, when you go to a grocery shop, they give us some coupons, and these coupons are quite fitting to what our needs are. So they are trying to predict our needs there. The descriptive analysis can be taken as, for instance, airlines companies. They keep changing their prices, so they do this. They're prescribing this for a futuristic purpose. So, um, so these kind of prescriptive, descriptive, and predictive analysis, if you put them 3 together, the entire process is called data analytics. Now, data analytics is a new buzzword these days. It's because we have new jobs created nowadays in the form of data scientists. Previously, our graduates were working as software professionals. Now, the same breed is called data scientists. So, what they do is they play with the data, they analyze the data in these 3 manners, and so performing data analytics, they come to a conclusion. Now, the entire process of data analysis goes right from identification of data. You need to know what kind of data that you need, and then the data is collected. The data acquisition itself is a broad field where different sensors, different kinds of data, calibrated data is converted to maybe analog, digital, binary, words. There's so many kinds of data that we identify and collect and then process this data. So the processing is basically um, converting data in the form that can be understood. For instance, the computer can only understand a digital data like binaries. So if I'm collecting analog data, I'll have to convert this into a digital signal to give it to the computer. So after processing, the data has to be cleaned. What does it mean? Is that the data may have lots of values which are not relevant to my kind of use. So I need to clean the data so that I only extract important data to give me further important information. So once I have cleaned the data, now I can put this data in some order, put into some kind of mathematical equations, maybe which we call modeling. It could be analytical modeling. There are various kinds of modeling that one can perform. And then after creating such kind of a model, the model outputs have to be communicated properly. For that, we do the communication. Talking about this data analytics, which is a new science and has emerged these days, and we can see lots of positions coming up for data scientists. It's because the data analytics being used in all the spheres of the world business. Talking about the finance and banking, they use it most because for them data is everything. But we do have use of data analytics in technology, manufacturing, energy, consumer, healthcare is also leading sector where we use data analytics. So when we do data analytics, I'm sure most of you can follow me that we mostly talk about classification and regression. Uh, to 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 briefly explain what classification and regression to many of us who are not quite adept with these skills and these terms, I have a simple example here. As you can see, the data is to be given. Uh, we first use a classifier and then give it a training data, and then the classifier, what it'll do, it'll classify the data in different classes, and we'll try to understand the rules behind it. So as you can see in this example, besides the names and the ranks and the years of experience, the tenure thing, the permanent thing becomes the output. So the classifier will form such kind of a rule, and it can be tested on some different data set. And once it works fine, then you can give it some unseen data and it'll give you an output. So the classification, it normally performed on the discrete data or classified data. Now, the other thing, if you have a continuous data, then you do regression analysis. Regression is nothing but it's like fitting a best fit line into the data. As you can see, this is the linear regression where you fit a best fit. But a best fit line may not always fit, so we may sometimes like to fit a curve, which is called polynomial regression. Sometimes we want to say give some tolerance to this fitting, so we use support vector regression. As you can see here, there's a hyperplane and there are two support vectors shown in this figure. We also use decision trees for regression. Lots of decision trees, they're quite accurate, they're quite fitting. When you have power, you can actually use many of such kind of trees together and make a powerful regression model that's called random forest. This ridge regression, lasso regression, they all fall in the same category of linear regression with varied capabilities. Um, so, so we understand that the machine learning has many these kind of techniques, but these techniques can further be divided into two classes, which are called supervised machine learning and unsupervised machine learning. Now, When you get the data which is labeled properly, then it's called then the algorithm that we perform on the data is called supervised learning. And when you receive data but it has no labels, you don't know what are these columns of data are representing. So in case if the data is not labeled, we don't know whether it is length, height, or age, or whatever. And then if you have to do some inferencing, some data analytics, then we use unsupervised machine learning algorithms such as PCA, MCA, and these k-means clustering and all that. Now the question is how machine learning is vis-a-vis artificial intelligence. Now, there's a clear-cut difference between the two technologies. There shouldn't be any confusion. Machine learning, it can acquire not learning through experience, but artificial intelligence, besides learning, can also gain knowledge from the systems. So, for instance, I'll give you an example here. We all have used such kind of games, played these kind of games before. You need to enter into this field and reach to the exit by avoiding these mines. Okay. Now, what machine learning will do is it will create many different paths and it will simulate and we'll see what works and what doesn't work, and we'll save those parts which have worked. And so next time when someone wants to enter, it would suggest different ways which can work. But the problem arises when these minefields they are rearranged, their locations are changed. Now the machine learning cannot work. It will have to be once again trained and then only it will work. Instead, if you use artificial intelligence, what it does is, um, besides finding optimal ways from entry to exit, it will also find out what these mines are and why these mines should be avoided. And so the next time when you rearrange these mines, so the artificial intelligence, it would suggest a path which can best avoid these mines and from entry to can reach to the exit. So besides experience, it also requires knowledge, and that's artificial intelligence. I'll give you a brief overview of artificial intelligence. When we when you're talking about artificial intelligence, we are definitely talking about intelligence, but we are talking about intelligence from humans, from insects, from creations, from nature. So this intelligence from nature is being used, extracted, and mimicked into algorithms. This is all about artificial intelligences. Um, for machine learning, where you have different algorithms for feature extraction and classification, in artificial intelligence, everything can be done in just one go with just one algorithm. We have right from the automation technologies, we have grown to use machine learning techniques such as regression, decision trees, and graphs. And then further improvements in machine learning let us perform supervised learning, unsupervised learning, reinforced learning. But what artificial intelligence does is it does so many things, such as voice recognition, language, natural language processing. It, it can perform computer vision exercises. It can help us with robotics, so many things. So I'm going to talk about artificial intelligence now deeply. Now, some might even think that this artificial intelligence is something, some sort of a software which is sitting into, which is only in silico, which is only sitting into the computer. It's not like that. Artificial intelligence is being applied to sensing. Uh, it is applied to understanding, and it's also applied to acting onto the physical systems. So we do have computer vision and audio processing where we do use sensors like cameras and microphones and speakers, and then we process the data to do something which can be used, and then to comprehend and to act onto the physical system again. So artificial intelligence is being applied to all these kinds of diverse fields. If you talk about adoption of these emerging technologies such as wearable devices, automation, autonomous vehicles, 3D printing, robotics, AR, VR, IoT is on top, but AI is just behind that. And in fact, we use a lot of AI, we, load up, we use a lot of artificial intelligence in Internet of Things as well. Now, as you all know, various business and sectors, they use artificial intelligence. For instance, in transportation, we use artificial intelligence to reduce our cost and avoid accidents. For health, we want to organize health care system so that we can enhance our living quality. Uh, for water, again, to find out new resources for water and organize the supply of water nicely. Artificial intelligence can be used. It is being used in technology, of course, for enhancing productivity and cost savings. For environment, we do use artificial intelligence to increase the forestation rate and find out the sedimentations. There are many things, dams, rainwater harvesting, so many things that we do for the environment using artificial intelligence. We also can control the traffic and avoid accidents, jams. There's so much potential artificial intelligence has in all these sectors. But then there are two kinds of artificial intelligence we normally talk about. One of them is called strong AI, which is not pretty much is in use, whereby computers can be on their own. For instance, um, if there's a machine and if I tell the machine good morning, the machine can should automatically make a coffee and give it to me. So that's kind of a strong AI that sits with this kind of machines. But these are not very common. What is more common these days is called weak AI, which can identify patterns, solve problems, can control process intelligently. There's another classification in artificial intelligence that normally is popular. There's one narrow intelligence and a general intelligence. So if I'm using artificial intelligence for a specific job, it's called narrow intelligence. And if my algorithms can work on more than one problem simultaneously, then it's called general intelligence. For instance, I can read facial expressions using a narrow intelligence, but if it is a general intelligence, it can also explain me why. So, like machine learning, in artificial intelligence, we do have many approaches, starting from artificial neural network, where we try to mimic our human brain. There is a method called genetic evolution, which kinds of compresses the entire nature's evolution process over the millions of years into into few iterations and can give us better improved solutions. There's cellular automata that we use fuzzy systems to deal with qualitative variables, linguistic variables, and then uh, the quantitative mathematics can be performed on, for instance, variables such as close to 2, more or less 5. They can be added or multiplied, and then all kinds of mathematics can be done on these kind of um, fuzzy variables. There are multi-agent systems, swarm intelligence. We do learn intelligence. We do extract and use intelligence, which is with ants, with birds flying in a swarm, intelligence into bees. All can be used in appropriate manner. For instance, ant colony optimization can be used, or ant optimization, where we extract intelligence of ants to find out the optimal path is quite popular. Let me quickly talk about what is neural network. In few slides, I might be slightly uh, giving you mathematical equations, but these are not clumsy, these are not cumbersome. Believe me, it's going to be very simple for everyone to understand because we are talking about human brain. And after this, probably you'll learn about human brain as much as a doctor knows about it. So our brain typically has billions of neurons, and they are further connected with many neurons. So they are very highly interconnected. Our brain, it weighs only 1.5 kg, and it has therefore weight of a neuron. One single entity of our brain is called neuron, and it weighs way less. As you can see, it's like 1.5 nanograms. The kind of computation and intelligence our brain does, it requires only 15 watts of energy. But if you want to do similar computation using our normal computers, they would require 15 million watts. So you can see how efficient or how efficient in terms of energy consumption our brain is compared to the normal computers. So our brain is 1 million times more efficient in terms of energy compared to normal computers. Um, what our brain does is it has a lot of neurons, and all these neurons are connected together. The neurons are connected together with dendrites. This is one neuron picture which I'm showing here. So through dendrites, they perceive all the inputs. All the input information goes inside, and then it's processed into the soma. Um, so there we have synapses, and based on how important this information is, the synaptic joints and the soma strength would be more. And then the neuron processes this information and then outputs to something called axon. I'll further explain this with a more zoomed in figure. So the information perceived through dendrites is processed in soma, and it is passed through axon as an output. So what it is being done actually is the information is given weights based on how important this information is, and then it is passed through certain function. Basically, in our brain, it's kind of a sigmoidal function that works on it, and so all the inputs multiplied by the weights are summed up and then passed through a function to give you an output. To further explain this, if I ask you to find out the multiplication of 5, 3, and 2, you would immediately tell me that it is 30. You actually have not calculated, you have not multiplied 5, 3, and 2 as such on paper or as such. It's just that it goes into your brain as an input, and because the command is multiplication, the immediate answer is 30. So this is because our brain has developed over the time some kind of a weight matrix in the form of synapse strengths. So what simply our brain does is it will give input 532, it will multiply with these weights, pass through this kind of a function. For instance, I'm showing it as a 10 hyperbolic function, and it gives an output. Now, all of us, we give the same result for 5, 3, and 2, but the process of thinking all of us we have is different. So we all have these weights in our brain, but all the values for these weights in our individual brains, they are not the same, they could be different. So this point should be noted. I'm giving you one more example, and please don't worry about this small mathematics I'm presenting in here, but this is important to understand how how our brain's neural network is mimicked into algorithms and how it works. We normally call it backpropagation algorithm. It's quite simple. As you can see, if I have input and output data, so this 246 is my input data, and my output desired data is 1.5. Now what I'll do is I'll try to create a neural network with input layer, a hidden layer, and an output layer. There are a few neurons sitting on the input, hidden, and output layers. Now, through input layer, the, the inputs 246 will be given to the hidden layer neurons, where they'll be multiplied with weights such as W1, and then passed to a function which is 10 hyperbolic, and then again multiplied with W2 weights here, and you get the output. But the output which you get is not the one which you actually desired. The actual output desired was 1.5, whereas here I'm getting zero point 0.8 and point 0.2, which is quite different. So what needs to be done is we need to change this W1 and W2 metrics, weight metrics. The values have to be changed in such a way so that you get accurate result. And doing so, in identifying those correct weight matrices, what do we do is we find out what is the error, and then this error function is differentiated with respect to the weights, and then the the the, the correction in the weight that we receive has to be included into the previous weights, and the weights are kept on updating. So when you keep on updating the weights, you eventually get a matrix which works for it perfectly. So here I'm showing one simple algorithm for some kind of a input and target data. If you run it, in my example, in 116 cycles, the error has been reduced to my desired limits. And now I have a perfect weight matrix, W1, W and V's, which will perform the multiplication. So if I give 532, it will immediately give me result 30. But if I change my input, it will still give me a multiplication result because it has been trained on the multiplication pattern. Now, what is deep learning? It is basically having more hidden layers into the neural network. And why we need a deep learning is because um, working with multiplication or addition kind of simple problems, it could be fine that we just have one hidden layer. But when we have so many things to identify, for instance, if I'm trying to analyze one image, as you can see it here, this image is given as an output and as an input, and as an output I need to know who this person is. So in deep learning we have various different hidden layers which will do different kinds of tasks. For instance, the first layer is identifying the ages. The second would combine the ages together, and then the third one would identify different features on the face to finally predict who this person is. Now, when you work with deep learning, these deep neural networks, we normally come across certain hyperparameters. And these hyperparameters should be selected before we start working on deep learning. To give you an example of hyperparameters, these are learning rate, how many hidden layers that I should use, and how many neurons should be sitting on each of these hidden layers. What should be the activation function that the hidden layers use? I mean, these are all hyperparameters. Now, we normally use, there are methods to find out these hyperparameters, and one of them is grid search. So we create such kind of a grid. I mean, I know my learning rate is between 0 and 1. So I would create grid of, let's say, 9 points or 16 points. And then I would check on each of these sets. That's called grid search. I can do a random search as well. And I can go for a Bayesian optimization as well. But the thing is, here I'll take a slide detour and I'll try to explain what genetic evolution is, because the similar thing, this kind of hyperparameter identification can be done using another artificial intelligence algorithm which is known as genetic evolution. Now what this genetic evolution does is it does optimization. It does, by default it will maximize something. Now the concept has been taken from nature where the evolution is happening. If you go by Darwin's theory of evolution, it exactly matches with what I'm going to tell you. We initialize the population, we try to find out what is the fitness of this population, which is called phenotype, um, and then I would rank these solutions based on the fitness. If I have an objective function and have many solutions, so I'll see which solution is excelling and which solution is not excelling, and accordingly the solutions are ranked. And then when you get better solutions, we try to match these solutions, we try to cross these solutions, put together to produce offsprings which are, to my surprise and going by laws of nature, they are always better solutions. So two good parents, they give rise to a better solution, again, which is offspring. And in the process we do discard the worst solutions, and this process goes on, and eventually you get a bunch of solutions which are really good, and you can use those solutions. Now here what we do is we go back to our DNN, deep neural networks again, and as you can see, uh, when I'm trying to find out these hyperparameters, so what I can do is I can encode this problem as an optimization problem where hyperparameters like learning rate, number of hidden layers, number of neurons in the hidden layer, and so on. So I can code everything in terms of binary, in terms of bits into a binary string here. So every DNN, as you can see there, I have 100 DNN models, and they're all identified with their hyperparameters, which I encoded into binaries. Now, all these solutions will go into this genetic evolution, and at the end, you'll get a solution, a bunch of solutions which are really good. So, in terms of optimization, I'll quickly try to explain that optimization is not always about maximization or minimization, because if you have two objectives to optimize together, it's not possible to reach to a maxima and minima. So what we do is we try to find a best compromise solution, which is called a trade-off solutions. Now, to find the trade-off solution, what you can do is you can add the two objective functions together by multiplying with different weights, and when you do so, you get a surface like this on or a curve like this, and it's called Pareto optimal curve. Now, to get this Pareto optimal curve between two objectives, you have to solve bunch of optimization problems. So one of these equations, each of these equations becomes one optimization problem. Now, there is something called evolutionary algorithm, which is again um, uh, comes under the purview of artificial intelligence. So we have this genetic evolution we recently talked about in the previous slide. And we can use genetic evolution, and what it does is it would solve all these equations simultaneously and can provide us in just one solving one optimization problem, simultaneously optimizing all these objectives can provide us all these Pareto optimal solutions. So once again, come back to this deep learning or deep neural networks that I was talking about. So I'm trying to optimize these deep neural networks, um, keeping three objectives in mind, which are it should be accurate enough, this area under the curve should be very good, and then there's another objective I have for my deep learning on neural networks. It's called F1 score. So basically, I want my neural network to be very accurate, but at the same time, I want it to be more precise and I want it to be more robust. Now, when you have many objectives, as you can see, I would like to find out those Pareto optimal solutions which would fare well in all these three criteria. So for this, we normally, in our research, what we do is uh, just don't worry about again this mathematics here. It's for the sake of only those who are inquisitives. So what we do is we do a bi-level optimization. So at the lower level, we identify the weight matrix and the biases and all that from the back propagation. And at the higher and the upper level of this optimization, bi-level optimization, the higher level, what we do is we identify these hyperparameters. So because I'm using genetic evolution to optimize my neural network, so we give it a different terminology, we call it neuroevolution. You would see how this neuroevolution works. But before I talk about neuroevolution, let me tell you the genetic evolution. There are many approaches already available. Uh, the most popular genetic evolution approach is called NSGA3. It's called non-dominated sorting genetic algorithm. Um, this was proposed by Professor Kalyan Meddev, and to your surprise, this one algorithm has been cited for more than 35,000 times. So what we have done in our research is we found some important opportunities of improvement in this NSGA, and then we proposed another evolutionary algorithm of our own, which can do better discrimination among solutions, and it divides the solution space into known quality spaces. We can provide exact termination criteria for this algorithm and can find the best solution from the Pareto optimal set. We have this publication, we deliberately published this paper into an open access journal called IEEE Access, so everyone can access this. Now, why I'm talking about this is uh, we have done some research. Now, what we can do with what we know will come now. So the first thing I'm going to share with you is that we've done some analytics in breast cancer data, and for that we worked on the biggest available database called SEER database from US, where they've been recording all cancer patients' data right from 1973 until now, and the database has more than 10 million data sets. Now, what we do is from the database, we do some dimensionality reduction, we clean the data, and we reduced it in terms of dimensions, and we came out with these 19 important uh, data for a patient. Um, so from this database, we wanted to find out what are the chances that a person would survive for more than 5 years. So we did such kind of uh, uh, prescriptive, yeah, a predictive analysis, which is also called data analytics. So uh, as you can see, what we do is when you have such kind of a data, which is both categorical and also continuous, you have to find out, you have to deal with those categorical variables like, uh, the race, the marital status, and these are the things which you cannot, you know, process using existing algorithms. So these categorical data has to be converted into continuous domain. So we do some kind of entity embedding thing here, and then it goes into the deep neural networks. We identify hyperparameters using our own fuzzy EFSGA, the new evolution algorithm I was talking about. But you can use any kind of evolution algorithm and find out the set of hyperparameters. And we also know what are the parameters of deep learning, and then the model will be created. And from Parrot optimal or set of all good solutions, we selected the final deep learning or deep neural network model, which works well for our breast cancer C data. And this is how it looks like. We did publish another paper in this same journal, and what it does is, what this software that we have created, what it does is it would take all the patient data I've discussed in the previous slides, and then as an output it would tell us the survival month. So all the zeros would mean that the person would survive less than 5 years, and the ones show that the person would survive for more than 5 years. Um, there's another class of neural networks which is called convolutional neural network. It works with images and can work with videos. Now, the problem is that uh, the CNN, it works on images, and the images are subject to many kinds of affine transformations such as shearing, scaling, rotation. Now, CNN, it remains invariant for translation. I mean, if I if I translate an image, the CNN is able to identify what image this is. But the moment I twist it, I rotate it, I shear it, it will not be able to identify. So what we have done is, with our new algorithms in CNN, convolutional neural network, we can actually identify a person if the image of the person is rotating and is scaled as well. So in this video, I'll show you this face and object detection part one. I would say this. As you can see, one of my students is wearing a mask here. So I need to identify who this person is and uh, the mask he has put on. So as you can see, there are two windows. One of the windows show name of the person, the blue one, and the green one shows that the person has put on a mask. Mind it, the person has rotated his face and still can be um, found, can be detected. This is another application that I have. So apart from the face, they are also able to detect objects so in the last video, as you could see that apart from identifying the persons there, we were also able to identify the safety gear that they are putting on, such as helmet, gloves, glasses, and so on. In this next video, what I have here, it's about a recent research that we've done amidst this new crisis that all of us are facing, this COVID-19. So we want to check, we want to measure temperature of a person to find out whether the person is sick or not. So these kind of system would be installed outside the malls and other places where we can, through the video, through the camera, we can identify who this person is, or we can better identify what the temperature of this person's body is. So if the person is suffering from fever, maybe the system would give an alarm, and you can follow this person and ask him to not to enter into the mall. So here's the video. As you can see, there'll be a small window. It might not be very clear, but you would see that there's a small window across around this person's face, showing the temperature of his body. Now that's that's one thing. Next, through our algorithms in using CNN, we're also able to find out. Uh, I mean, just looking at the person's walking style, we call it gait. We can also figure out who this person is. So this kind of gait recognition, we call it, is quite useful for video surveillance and security applications. So you want to follow a person through cameras, use his gait. So we we use from his gait, we produce this gait energy image, and then we try to find out who this person is, and we can follow him. The other thing which we can do is, um, once again using the same CNN algorithms, given a video, the computer, the algorithm, can make out what this video is all about. And as an output, my algorithm will give me a textual output showing, I mean, describing what is there in the video. So the video description is shown in a textual form. Here's the video.
Get
The
your
first video,
filling ready. Delicious chocolate pudding. Measure 2/3 of a cup of sugar into a medium saucepan. Then add 1/3 of a cup of unsweetened cocoa. Get your
so this was a
filling
video
ready. Delicious.
of a woman. She's cooking in the kitchen, and my model also gave me output saying that a woman is cooking in the kitchen. So for that, the CNN was given two kinds of inputs. One was the audio, the other one is this video which you're seeing here. The two signals of audio and video, they are concatenated, and then it goes into the predictor to give us a prediction. So it was done by my master students here. There's another video, as you can see here.
Oh, you can't take a bath right now, love. Okay, we got it all done.
So after going through this video, my model gives an output saying that a person is playing with a toy. So the description quite exactly is matching with the video. In another video which you can see, it's a video of a man driving a car, and the model output again says the similar thing, that the man is driving.
Oh, you can't take a bath.
Now, besides these interesting applications, we also work in healthcare robotics and use a lot of artificial intelligence um, algorithms, techniques there. So for healthcare, we're basically working in assistive and rehabilitation robots, like helping people suffering from stroke. Um, um, so I hope you understand what is a stroke, and after a stroke, people become disabled. They need support to walk or do things. So we have created exoskeletons which can help people walk on the treadmill, move their foot ankle around, move their hand around. So all these exoskeletons, they involve a lot of artificial intelligence in terms of design optimization, designing intelligent controllers around. And as you can see, this is quite interesting mechanism which was designed for ankle joint. So it can provide all three kinds of rotation degrees which we require for our ankle joint to move. And the robot here, we created another robot for upper limb rehabilitation. And the important thing here was that this robot had an intelligent controller which would take inputs from your brain. So it works from thinking. A person thinks and the robot works accordingly. We actually got an award for this kind of a robot. I'll tell you about this later on. So what we do here is we, apart from the exoskeleton, we also create the entire platform for neuro-rehabilitation, where we use a lot of computer vision. We let these patients work on games, wearing exoskeletons. They can see something. They are given targets. While playing games, they are doing exercises. Very interesting. Next, there's another application of AI in robot design and control, where we try to create a robotic platform for bone fracture. So when your bone is fractured, it goes like this because the muscles around it, they're pulling it. So you need to pull it back. It's called traction, and then align the bones. So we are creating, we're still working on this project, a robotic platform, which would take, using computer vision and intelligent control algorithms, it would it would do the traction and would fix the bones, which otherwise require many iterations. So recently, we were one of our robotic device. It was considered in one of the top 20 innovations by UNICEF, and we were invited to Geneva for a talk. And later on, we were given a World Bank grant to keep working on these kind of projects. I have a startup company here with students, and the company's name is Relive, and we do many such kind of projects, very interesting ones. So I hope you like this video. I hope you like the videos and my talk. If you have any question, you can you can write on your chat window where I can see. And thank you for watching. So I believe you all like this talk, which I can see from the comments. I would definitely like to answer all your questions. Please put your question into the chat window where I can see and I can try to answer the questions. If you don't have any question, I would like to close this task, and end this now. Okay, thank you very much.